Hi, I'm Chad Lawson. This is the Russian rocket retrofit, and you're watching Verbose mode. Welcome to Verbose Mode, the show dedicated to learning to learn and the freedom to fail. I am your host, Chad Lawson. Today we're going to talk about this gorgeous Russian lamp. It's from roughly mid-century, last century, obviously, and it was a gift from my wife. I'm going to have some links in the show notes to various other versions of this on eBay, all very similar. But she had found this on one of those retro Facebook pages, showed it to me, and I cooed over it, and so she managed to find one and buy it for me as a gift. Now, originally the lamp, and I'm going to go to the overhead here. This is the base of the original lamp. So first of all, let me just talk a little bit about the lamp. We've got this nice clear plastic here going up to a silver painted rocket, but the base has all these wonderful symbols. It mentions stuff from 1917. There's another reference to 1945. So we know the lamp is at least beyond that. I don't exactly remember the year of the lamp, but I think it looks older than it actually is. But when you took apart the base, when you removed it, this is what was in there. Now, I have since cut off the wiring, but this was originally set up to connect to European. The other end of this was a European plug. And this obviously came into this little divot here in the base. And there's the transformer that then steps alternating current down to a nice simple, and this might even still be alternating current, but drop down the voltage to this silly little lamp. So the first challenge was, of course, getting, I originally just bought an adapter online to go from European to American, plugged it in, and this little lamp barely has any power to light that up. And I've seen a few more of these lamps online, and yeah, it's the same base no matter what. So some of the other variations, though, I've seen for the lamp are that the rocket thrust that you have here is the entire plastic is red. Now in this particular one, I'm going to go back to overhead. There is a red filter here, so when a white light shines through, it comes into this looking red. So this way, I kind of like that, and I've been thinking about possibly making some changes to this, but even the pattern helps. Just simply shining a white light through does wonders. And I don't know if I can quite get this on camera. Yeah, kind of. There's a green ring so that when it's coming out through the side, even a white light shows green. So I wanted to make some other changes to it, and different ways. I was just simply going to use a microcontroller and some NeoPixels, some RGB, some microcontroller controllable lights to do various patterns and animations. So I want to talk a little bit about the different things I had to come up with for this project. It should be incredibly straightforward. It's a simple coil to take main power down to a reasonable power and a light source. That's all I had to do. But of course, being who I am, I over-engineered the snot of this. Because at the same time that I received the light from my wife, I just received a packet of, and I'm going to go to the overhead, these. This is an ESP01. So you can see this very small little 2x4 header here. But what we've got an antenna, and we've got a little microcontroller and ESP chip that can connect to Wi-Fi and receive commands. I picked up 4 of these for like $5, and I really wanted to play with this. Plus, when you took apart the base here, the amount of space that I had would have been perfect for a ring and one of these. And then that way, my goal was, and this is where I say I over-engineered it. My original thought was that I would take this, and this would be my chance to learn about these little ESP01 boards, both in terms of programming it, because unlike a lot of other microcontrollers, there's no USB to simply program it that way. I was going to have to use another connector to hook up to it and to send new code to it. So this is going to be a chance for me to first learn how to program this raw header, to wire it properly without burning it out, because this is a 3.3 volt system. Most of what I do is 5 volt. But also, once I got the code sent in here, my plan was to use what is called OTA, over-the-air updates, so that once I got some code on here, I could then send any updates. I could just have this plugged in, sitting anywhere I wanted, and send updates wirelessly. So this was going to be this was just because I had an excuse to learn this that I was doing it. It wasn't because I thought it was the best idea. By no means is this the best solution for simply lighting up some NeoPixels in a lamp. But I find that I learn things best if I have a reason to learn it, a project to apply it to. So I set out for a ridiculous amount of time learning how to program these. And the first thing I found is this little programmer that I was able to buy on Amazon for $2 or $3, but it has that same header, it has a capacitor on it, and it has an FTDI, USB to FTDI connector. So it handles all the translation that I would need. Where did I put the little sucker? There he is. These things are so small, you have to be careful. So all I should have to do is plug this in, plug it into my computer, and go. And it was easy. I plugged it in, I set up to my computer, and could not send any code to it. Spent a lot of time banging my head on a wall on that one, thinking maybe I had problems with my drivers, thinking that there were, I kept finding things on forums suggesting, oh, the problem is this, the problem is that. Before finally finding the right set of circumstances, there are 2 pins on the bottom of this, because this device is meant to be a UART, a serial communication device. It wasn't designed to be a programmer, and the ESP01 requires, in order to be in programming mode, that these 2 pins, it's really hard to see that in this light, isn't it? These 2 pins be jumped together. So I just simply soldered a switch onto this so that I can switch it between UART mode, so I can just communicate with it and use this as a serial console, or to have it in programming mode and send new code into it. So once I had that figured out, suddenly I was able to send code to this. No problem. Everything's working great. And I started putting together a little piece of permaboard that had the light ring that I wanted, and everything was going great. I even got some basic OTA code to send. But then I realized this thing only has, there are a number of different models for this, but the ones that I bought are the 2nd generation of these boards, and they have 1 meg of flash memory. So the library that I was planning on using for driving the NeoPixels took more than that. So I wasn't able to quite get at what I wanted to have: the OTA code, the libraries for that, and the libraries for the NeoPixels all in one tiny little device. So I found myself being torn for a couple of days, because on one sense I'd accomplished what I set out to do. I had figured out a way to build this thing so that I could do over-the-air programming and learning it within the context of this rocket lamp, only to find out it was the wrong choice. So there was a lot of time spent on this. Now, what's stupid about that, if you will, not so foolish, the wish I had thought of this earlier, that whole freedom to fail, I had to give myself that freedom to realize that I'd made a mistake and I was going to find a new approach. So I started looking at other possible microcontrollers. Because if memory was the issue, I have other, and this is only just a couple of them, I have other ESP-driven microcontrollers that I could use that have a lot more memory and a lot more pinouts. But the thing is, I only needed 1 pin. And I'll show this for right now. I'll tease this right now. I only needed 1 pin to drive this ring of lights. So I started looking at other possibilities. I have other small microcontrollers. I have, this is I'm blanking on what this is called offhand. This is the first non-Arduino compatible device I started playing with. Teensy, that's the name of it. This is a Teensy. And then I have, this is a fairly generic Arduino Micro Pro that I picked up online. I picked up a batch of them. So I have other, but this has a ton of pins. This has quite a few pins. This is overkill for what I needed. So I ended up going to Adafruit's pool, and I already had a number of these in my collection, so I'm kind of disappointed that I didn't come up with it earlier. This, if I can detach it from its header, is called the Trinket. It is uses an AT-Tiny chip, so it only has 5 GPIO pins, 0, 1, 2, 3, and 4. There's also then power, ground, USB, and a couple of those pins should be considered reserved for if you're going to do any serial communication. I have to have it disconnected from my project if I'm going to send USB if I use one of those 2 pins. For the first time in using one of these devices, because I have used trinkets in other projects, and I keep putting them directly inside permaboard, meaning I don't put any headers on like this. I put them directly into the project, and then I need to send in new code, and I can't because it's pulling down or pulling up one of the pins that it's going to, either lights or a sensor or something like that. So I was really proud of myself for learning this and figuring this out after having made those mistakes to put, well, let's do this, to put these little female headers on here so I can easily pull the chip, pull the trinket out. Now, of course, it's funny because no sooner do I actually finally remember to do that, that I also remember not to tie down any of the pins I need for USB. So I managed to fix a lot of problems at once, any one of which would have worked, and I managed to get them both right at once. I also want to point out that in addition to that header that I found, that this little $2 gizmo, the other option I had, and what I was originally when I was stumbling with this, and I found that particular that I needed to switch that over. Somebody else had recommended, one of the other examples I found is taking one of these, and I had these in my collection already. It's a USB to FTDI, same exact chip as you saw on that programmer, just going directly out. One of these, and I don't remember which without looking, and I know I'm not going to get it close enough. One's from Adafruit, one is from SparkFun. One happens to already be at 5 volts, one happens to be at 3.3 volts. I haven't made any modifications to either of these. They can be switched with these little solder pads on the back. Actually, it doesn't look like this one can. This one can be programmed. And I have another one I picked up recently that has a physical switch on it. All I have to do is toggle a switch to go between the various logic levels. So I spent a fair amount of time just trying to figure out what controller to put in here because all I needed was 1 pin. That's all I needed. Ideally, I'd like to have 5 volts. It's the most likely, the best voltage to use with my little LED ring. In fact, that was the only part that was extremely easy to me, was messing around with what I was going to use for the ring. I had a couple of these in stock. It's a NeoPixel ring from Adafruit. I'll have the link in the show notes. I had this little piece of permaboard I bought online. So the next challenge I had, and this is where a lot of the learning for this project came into place, was figuring out how to make this base and to mount this in. The original one, as you saw, was this one. It has the 3 holes. It has this little indent here for running the cord through. So I wanted to be able to reproduce this, and I started playing with Tinkercad. Tinkercad is a free website to do 3D modeling. And when I was first introduced to it, I thought it was overly simplistic. I didn't think there was much I was going to be able to do with it. But I watched an episode of Know How with Father Robert Balasar and a couple of other colleagues of his, and I'll have a link to that episode of their show in my show notes as well. And watching him do that and seeing some of the work over the time with his show that he had done with 3D printing using Tinkercad, I realized, all right, I'm never going to, well, not never, it's going to be a long time before I get to Robert's level, but I figured I ought to at least get started. So I started working on different designs for it. And the first challenge I had to come up with was just getting the measurements for the disc. So I took a piece, a caliper, measured out the width of the entire base, measured out the width of the inner drop, measured out the other pieces of it. I was able to do that fairly well. I also borrowed, thanks to the Tinkercad community, somebody had already made a simple little thing, a single little item that was an M3 screw mount. So that's what I have here, is these 4 little screw mounts for an M3 machine screw. The bigger challenge, though, is trying to figure out how to place these holes to mount the entire thing into the rocket. For that, I started with the process of laying everything out in the 3D space and putting the holes, measuring out where they need to be, but trying to find equidistant 3 spots was proving to be a bit of a challenge for me. And I'm doing overlapping squares and everything, trying to lay everything out before simply handing it to a friend of mine who was able to bring it up in between Tinkercad and another 3D program he has, and very quickly automate saying put one here and then rotate around, dropping it in even intervals. So I just simply took that from him. Now, going back to the overhead, this was the first one that I made. Once I had it rendered out, I 3D printed this. I'm relatively pleased with the way it came out. There's a little bit of weird scarring, scraping. Something happened where it was uneven. But what's really bizarre is, let's see if I can get this on camera, this little build out. There's a little spot here that just completely puffs out, and I didn't see it because I wasn't completely watching the 3D print, which you should never do. Always watch your 3D prints. Never let your 3D prints go unsupervised, at least not for as long as I was doing. And so it kind of created this weird little bump, and it just kept getting worse. But by the time I noticed it, it was only a couple layers around from being finished. Okay, I'm not going to worry about it. But the challenge was, turns out I had placed these just simply using a square. I just drew a square and then placed each of the pieces so they were on a corner of that square and laid it down. I had placed these using a different piece of permaboard. So now all of a sudden that I had found the permaboard that I wanted to use, this little square, I didn't have this placed right. Okay, fine. No big deal, just go back to the software, spend a little bit more time remeasuring everything out. In fact, all I had to do was, because I did it in a couple of different Tinkercad projects, and I'll have all of them available within the show notes. I'll make them public. They're horrible. I'm not even going to pretend that they're good. They're just adequate to get this job done. So I went back to Tinkercad, changed that rectangle to a square, realigned the 4 pegs, joined everything back together, copied it, went back to my disk. That was a collaborative project between my friend and I, whatever, and then brought it back in and did this one square. Now, what's cracks me up, I don't know if you can tell, this is the second one. The pegs are a little bit more, they are square in their distance. They're not still quite centered. I didn't quite do a good job of lining this up, but that exact same bulge, if I bring this up, it's in the exact same place on both of them, the exact same spot. And I'm not sure why, because for both of these, each time I printed them, I recalibrated the level of my print bed. These were printed a couple of days apart, so it's not like, and I had printed other things in between them, so it's not like it was using the exact same calibration or the exact same setup. So I'm not sure why, but after getting this one printed, I quickly found out one other challenge. I didn't have any M3 screws in stock. So I really wanted to get this done, and I really wanted to film this episode about it. So I didn't want to waste time trying to find. I went to my local Ace Hardware, and they had M3 screws, but not of the right length. And I just like, you know what? Fine. I have an absolute ton of M2.5 screws. So all I have to do now is go into my back into my software and redesign these mounting holes for 2.5. Now, let's see if I can get to the right spot. No, you know what? Never mind. I'm looking all over. I just have to grab it off the table. I ended up making this. The original screw holes that mount, whatever you want to call it, that I'd received from online, it was for an M3, but itself was actually made at 3.5 millimeters from the inner diameter. And I didn't know if there was some give in it, so I, not wanting to print out multiple ones of these, not wanting to do this because this is a 4-hour print on my printer, I wanted something to confirm the size a 2.5 and M2.5 screw would actually fit into something. So what I did was I just made a simple little rectangle in Tinkercad, and I made a hole. I made a cylinder and converted from shape into hole for 4 millimeters, 3.5, 3 millimeters, 2.5 down the line. And while it doesn't really show up well on this camera, I then put the text and turned the text into a hole and sunk it in so that I could then read and confirm. Although once I actually saw this, there's a big enough difference to know this is the small end, this is the big end. And then I just took the screws that I had, the 2.5s, and put them down the way, and sure enough, a 2.5 screw goes into a hole that's 2.5. So I'm not sure why the holes that the other guy had made for the M3s were 3.5. Not going to worry about it because I got what I needed. So I went ahead and then started another print job using those 2.5 holes, got everything recentered, and now I have this. Now, oddly, this one does not have that weird little bulb. Now, one of the challenges to printing this, and I didn't show the bottom of either of the other ones, because of this lip, I had to use what are called, I had to use the little risers. I'm trying to think of the name of the term. Adhesion was a raft support. So the support structures is a setting within your slicing software to determine that if you've got a space here and then something that builds here and there's overhang, you can use these support structures, and there's various formats for them where it will print kind of, in my case, a little back and forth grid. And it's just a little skeleton that gets printed up where there would normally be air, so for this under part, and then it prints then the outer lid on top of that. And then you have to shave this off. Now, in this case, this is all very rough. I could spend some more time with a sharp blade and just trim this out, but I got what I needed done for now. So it's a little bit rough, but oddly I don't have that weird bulb. My M2.5 screws fit in, as you can see. And I took this little piece of permaboard. I created a couple of female headers for the 5 pins for the trinket. I have my NeoPixel, which the way they designed this ring is nice because there's 1, 2, 3 solder points nicely spaced out for this particular square. It's not perfectly aligned for this for permaboard, for breadboard alignment. It does require a little bit of give, so I just simply took wire, a solid core wire, put it in here, and then threaded it through the hole so that way it had a little bit of give I needed, and then soldered it down. In retrospect, I should have probably, because there is another hole over here for data out, which while I don't need for this, would have created a little bit of extra lock to hold this into place. So as you can see, this works out really well, and then I can just run a USB cord. Oops, I have to actually put the thing into place. So the trinket then just fits right in here, and all I needed was the 3 wires, one to go to ground, one to go to power, one to go to data. I think I have those right in the right order, and simply connect my USB cable. Does help. No, I actually had it right. No, I had it right the second time. Don't you love that about the current USB? The reason I'm actually glad we're going to the USB standard is so it doesn't take you 3 times you have a 50-50 chance of putting a USB in right, and you're going to get it wrong 2 times. I don't know how that works. So once I get this placed in here, then all I have to do is line it up with these holes, run the cord through that little give, and everything's great. So the other reason that I like the way I've got this set up right now is when I've got the USB cable plugged in, as opposed to doing just a standard DC, is it's easy enough to come in here, take this out, pull the trinket out, do something else with it. I could run a DC header onto it. I don't know that I necessarily want to, but also by using this USB cable to power it, and I have this nice little power brick. I'm not sure where I got this, probably Adafruit. I tend to get the first thing of everything from Adafruit to test with it. If I end up buying in bulk, I might go online to see if I can find it a little bit cheaper. But I love going to Adafruit, especially for the first time I'm buying something and playing with it. But this just simply plugs into the wall and has USB out. This one is 5 volts, I believe 2 amps out. So I wanted to make sure that I had enough power draw to have that. It's severely overkill. I did not need everything I had in here. But this way, if I don't have it plugged in for power, I can take the USB out of the power brick end and plug it right into a computer and send in new code. And because I did manage to make sure that I don't have any of the wires connecting to one of those, I don't have my data line sitting on either the USB, what do you call it, the the transmission or receive, TX, RX pins, I'm not duplicating that. I can simply send in new code with it sitting still plugged into the rocket. All I have to do is move the USB cord, and I can get other adapters. I mean, there are cheap adapters that I could get at Walgreens for like 25 cents to do USB to power, but I wanted to make sure that I had the right power, and I didn't want something that was cheap that might end up exploding, because after all, I'm the one that designed this. I don't know how well this is going to work. This thing could go absolutely crazy. So this has been a fun project for me. I've thought a lot about, and one other thing, talking about the light fixture. While I had decided early on that I was going to use the rings, I also have this little thing which only has 5. And so one thought was, within my permaboard, I could move the trinket over here and then have the little light jewel over here. That would have done a better job of what I have going on. When the USB comes in, it's now sitting directly overneath a couple of these pixels. This would have solved that, but it's not quite as bright. It's not quite as much lights. The other thing I considered doing at the time, and this is just one that happens to have alligator clips for testing, but I've still considered taking a strip and lining it on the inside ring here. There we go. Lining it along the inside ring so that it could shine out through this. I've looked at what I'm going to have to take apart in order to remove either this red disc if I wanted to, or this green ring. I'm not sure I want to at this point, but I could, and then I wouldn't have any problems with light filtering. So the last thing that I had to then figure out for this was coating it. So I've got my light picked. I'm happy with it. I've got my mount printed and done. I'm happy with it. I've got my board. I'm happy with it. Everything's great. The one piece I actually had done right off the bat, the day that my wife gave this to me, I took out the internal guts and I took a simple little breadboard and an Arduino Uno. And at the time, that ring that you saw, I originally had, I told you there's wires that are just going through here. I originally had male headers, simple little breadboard headers on this, and I could fit it perfectly where you see the 3 wires here, and I could just drive it from the Arduino. So this code, the code that's sitting on the Uno, just simply runs the animation. So this has actually been, while I've been working on the rest of it, while I've been trying to develop the 3D printed base, while I've been trying to figure out how to do an ESP01 coding, while I've been trying to figure out all these individual pieces, I've still had this breadboard with an Uno plugged into the wall and the rocket just sitting on top of it, just so that we could have the animation going and just being pleased with it. So it's worked really well. I'm going to make it look, I'm going to go ahead and change camera angles. I'm going to put the rocket back together, and I'm going to show you the animation I currently have going. All right, we're back. I've got the light put together, all connected into here. Instead of bothering, because I did not design this set with the idea of having power outlets this close to the bench, I'm going to just simply use a USB battery pack for this, but it also shows the flexibility of this. When I first plug it in, the trinket itself has a fairly long bootloader. I don't know that, wasn't that long this time. But the animation that's going, all I'm doing with this, the only thing going on in this code is, if you take a look at the NeoPixel sample library, I just borrowed from that. I'll have my code, and I'll try to put in some comments that show you the differences between the original code and mine. It's just a couple of things about changing the pacing a little bit and changing how many times to do a given animation. But because I'm borrowing from the fact that there's the red filter coming up through the base and the green filter coming around the side, the animation starts off with 3 passes of first lighting up the ring, just circling around the ring, turning it on in green, so that way it shines through the green light and the red filter filters out most of it. Then it does it in white so that it shines both through the top and sides, and then it does it again in red so that it also looks like it's mostly just coming out through the top here. Then it runs into another animation. In fact, here's that right now. Then it's just borrowing one of the cycles, and it's cycling through green, it cycles through white, it cycles through red, using this little dancing pattern. I think they call it marquee or something like that. And then it's just using a couple of the rainbow cycles and then the rainbow in total. And depending on as it goes through the entire spectrum, certain parts of it have more red, have more green, and show through their respective things. So this is the most boring code ever for now. My plan in the future is to come up with some new animations, make it a little more elaborate. I'm obviously not going to be doing it over the air, but now I can just simply unplug this, plug it into my computer without having to take it apart, without having to remove the microcontroller to give it new code. The other augmentation I'm thinking about doing in the near future, somewhere around here, and if you ever see my workbench, you'll know that there's no way I'm finding it right now. I have a cord that is just I think it's just a USB cord that has a little rocker switch in it. So I could actually run that in between these two to have a little rocker switch that I could then turn this on and off and just leave it plugged in all the time that I'm wanting to use it as a lamp, and then toggle it back off just to turn it off instead of having to plug and unplug it as I am now. So that's kind of the gist of where this project is and where I've been going with it so far. It's been a fun project. I've learned some stuff. I've learned that I over-engineer things more than I need to, but I think we've proven that to do everyone by now. But I learned a lot about 3D drawing, more than I ever thought I was going to be able to do. I've obviously learned more about 3D printing and the mistakes that I can make. And while some of it I don't know why, I've clearly seen what can happen. It's been a good learning experience of figuring things out, things that I didn't know. The code, right, at this, quite frankly, is the easiest part because it's just borrowed code that is slightly altered. I didn't do anything sophisticated with it, but I had tried to learn over-the-air programming, and while I've learned a little bit, it's obviously not going into this project, but it's been a good learning experience. As you can see, I've made plenty of mistakes, from simple mistakes to more complicated mistakes. I haven't killed anything this project. Surprisingly, I seriously expected I was going to burn out one of the NeoPixel sets. It seems like every time I do any sophisticated NeoPixel project, something about the way I connect and disconnect things during testing. I'm also going to put in the show notes Adafruit's, what do they call it, their Uber guide to NeoPixels. Please read that if you're going to be doing anything with NeoPixels. A couple of things on there I thought were kind of silly. They have a recommendation of putting in a capacitor at the power line to make sure that it's good, clean power going through it, and to have even some simple little resistor between the microcontroller and the data line. I have put together plenty of projects without those that have been fine. In fact, I've got one upstairs that has been running for years and it doesn't have either of those, and it's been no problem. But I have another one upstairs with a slightly denser, even though it's a shorter run of NeoPixels, it's double the number of NeoPixels per inch. Per meter, I should say. And that ends up meaning it's more lights than the first one. And it was having some weird flickering for a while. And as soon as I went ahead and went back, took the controller box apart and put in the capacitor and the resistor, I started having a lot cleaner. It hasn't given me any problems. There hasn't been any flickering or any other issues. But I've worked with my little brother, whom I've mentioned before, to do a lighting project, and we burned out 2 light strings while testing, before remembering that, yeah, whenever you're hooking up power directly to like a light strip like this, you first connect ground and then power. I forgot to tell him that, and power would get hooked up first and then ground, and all of a sudden we'd wind up with, because we didn't have the capacitor on there, we'd wind up with a completely burned out strip. Now, in all likelihood, I could trim the first 1 or 2 off of it and it'd be fine down the way. I haven't gotten around to it yet. But I'll definitely put that Uber guide in there, because if you're going to do any NeoPixel projects like that, it's just a couple of those little considerations. The guide has great information on about how to calculate your energy draw, the current draw. The other link that I'll put in there is for a couple of other links that I found for other WS2812, which is what a NeoPixel is. That's this other word for it, but NeoPixel is easier to say, right? A couple other libraries for different animations. So I'm going to start tinkering with some of those more, both in this project and future ones, to have other little sparkling patterns. The one that I started writing on my own last year, if you remember the Christmas lights episode, for the Christmas lights, I had just simply the lights change. I want to do some sort of twinkle, but I'd have to do it in different cycles and just keep track of, okay, I've got the strip of lights, and if I want to have something twinkle, I choose a random one, have it go full bright, and then every single cycle through have it start counting down. In the meantime, every single cycle, it's potentially picking another light to go to full brightness. So every cycle there are lights at different stages of brightness, and I have to know where each one of them is in terms of set and step it down and then keep track. Whole animation process I was dealing with, and it turns out after spending some time with that, somebody has a library to do exactly that. So if I can find it, I'll post that link as well. I hope this has been at least of some interest. This has been a fun project for me. I hope it's been fun for you. As always, if you like the show, please go ahead and give us some information. You can email us at feedback@verbosemode.tv. You can find us on Twitter at verbosemodetv. And we have a Facebook group. You can find us through Verbose Mode TV. It does require a quick little sign up just to keep spammers out, but there's a simple little question you answer, and I approve everybody pretty much within a day. I just want to make sure that we have that in place so we don't wind up like some of the other pages I've had to administer. Also, you can find us on Patreon. If you like the show, please feel free to subscribe to us there. We'd appreciate it. And until next time, try again, fail better.